Testing is an essential part of the software development process, ensuring that a program functions correctly and efficiently while minimizing errors. Programming errors can be broadly classified into syntax errors and logic errors, both of which can significantly impact the performance and reliability of a program. To systematically identify and resolve these errors, developers create a test plan before implementation, allowing them to anticipate potential issues and ensure that the final product meets its intended requirements. Syntax errors occur when a program does not conform to the rules of the programming language being used. These errors prevent the program from running because the computer cannot interpret the instructions correctly. Common syntax errors include missing punctuation, incorrect use of keywords, or mismatched parentheses and brackets. For example, in Python, forgetting to indent a block of code properly can result in an indentation error, while in languages such as Java or C++, missing a semicolon at the end of a statement will cause a compilation error. Syntax errors are usually detected by the compiler or interpreter, which highlights the issue and prevents the program from executing until the error is corrected. Resolving syntax errors is generally straightforward, as the error messages provided by the development environment often indicate the location and nature of the problem. Logic errors, on the other hand, occur when a program runs without crashing but produces incorrect or unintended results. These errors are more challenging to identify because they do not prevent the program from executing. Instead, they lead to unexpected behavior. Logic errors arise from flawed reasoning, incorrect calculations, improper use of control structures, or unintended interactions between different parts of the code. A simple example of a logic error is a program designed to calculate the average of a set of numbers, but mistakenly dividing by the total count minus 1 instead of the total count. Since logic errors do not generate immediate error messages, they require careful testing to detect and correct. To effectively manage testing and ensure that all potential errors are identified and addressed, developers create a test plan before implementation. A test plan is a structured document that outlines the approach, objectives, and methods for testing a program. It serves as a roadmap, ensuring that all aspects of the program are examined systematically. The test plan typically includes test cases, expected outcomes, and criteria for determining whether the program behaves as intended. By developing a test plan in advance, developers can ensure that testing is thorough and methodical, rather than being an afterthought. A well-designed test plan covers a variety of testing techniques to identify different types of errors. One of the most fundamental approaches is unit testing, which involves testing individual components of the program in isolation to verify that they function correctly. By testing small sections of code separately, developers can identify errors at an early stage and resolve them before they affect the entire system. Integration testing follows unit testing and ensures that different modules of the program work together as expected. This type of testing is particularly important in complex systems where multiple components interact, as errors in data flow or function calls can lead to unintended behavior. Functional testing is another key aspect of a test plan, focusing on whether the program meets its intended specifications. This involves testing input-output relationships, ensuring that user inputs produce the expected results, and verifying that all features perform their designated tasks. For example, if a program includes a login system, functional testing would confirm that valid credentials allow access while incorrect ones are rejected. Boundary testing is also an essential component of a test plan, particularly when dealing with numerical inputs or data validation. This technique examines how a program handles values at the edges of acceptable input ranges. For example, if a program is designed to accept numbers between 1 and 100, boundary testing would check how the program responds to values such as 0, 1, 100, and 101. Identifying boundary-related issues prevents unexpected errors when users enter values near the limits of acceptable input. In addition to structured testing techniques, developers often use debugging tools to identify and resolve errors. Debuggers allow programmers to step through code line by line, examine variable values, and track the execution flow of the program. This is particularly useful for identifying logic errors that are not immediately apparent through standard testing methods. By observing how the program processes data and executes instructions, developers can pinpoint the source of an error and make necessary corrections. A robust test plan also considers user experience and usability testing. While a program may function correctly from a technical standpoint, it is equally important that it is intuitive and user-friendly. Usability testing involves gathering feedback from potential users to determine whether the interface is clear, the navigation is intuitive, and the program responds appropriately to user actions. Addressing usability concerns ensures that the final product is not only free of errors, but also accessible and practical for its intended audience. By implementing a comprehensive test plan before program implementation, developers can systematically identify and resolve errors, resulting in a more reliable and efficient program. Syntax errors, which prevent execution, are typically identified during the initial stages of development, while logic errors require thorough testing and debugging to detect and correct. A structured approach to testing, incorporating unit testing, integration testing, functional testing, boundary testing, and usability testing, ensures that all aspects of the program are examined. This methodical approach not only improves the quality of the software, but also reduces the time and effort required to fix errors later in the development process. Ultimately, investing in a well-defined test plan leads to a more robust, user-friendly, and maintainable program.